common issue with arc fault circuit breakers is nuisance tripping, but let's explore some potential causes and troubleshooting steps when an arc fault breaker trips. Firstly, consider the possibility of an overload condition. Check if too many devices or appliances are plugged into the circuit simultaneously. Unplug some devices and try again to see if the breaker holds. Secondly, examine the wire connections. It's critical to verify that all wire connections, including any splices, are tight and secure. Loose connections can create resistance and heat, leading to arcing and subsequent breaker trips. Thirdly, a defective circuit breaker itself could be the culprit. Replace the arc fault circuit breaker, often abbreviated as AFCI, with a new one to rule out a faulty breaker. Fourthly, even if the circuit passed inspection, there could still be an underlying wiring issue. Inspect the wires for any damage or insulation breaches that might not have been apparent during the initial inspection. Fifthly, confirm that the correct wire type was used for the circuit. Ensure you have used the appropriate gauge wire, typically 14 American wire gauge or 12 American wire gauge, depending on the circuit's amperage requirements, as dictated by the 2017 National Electrical Code. Sixthly, be aware that arc fault circuit breakers can sometimes trip due to electrical noise or interference from other devices. Try unplugging appliances or electronic devices located near the affected circuit to see if this resolves the issue. Seventhly, specific brands or types of arc fault circuit breakers, such as Homeline AFCIs, have been known to have a higher false tripping rate. If other troubleshooting steps fail, consider replacing the Homeline AFCIs with a different brand or type of arc fault circuit breaker. As additional troubleshooting tips, use a voltometer to check for proper voltage, which should be approximately 120 volts, and continuity on the circuit. Also, try plugging a single appliance or device into the circuit to isolate the problem and determine if a specific device is causing the breaker to trip. Article 210.12 of the National Electrical Code, or NEC, mandates the use of arc fault circuit interrupter protection in many areas of a dwelling, including bedrooms. Arc fault circuit interrupters are designed to detect unintended electrical arcs and energize the circuit to prevent electrical fires. The NEC defines an arc fault as an unintentional arc created by a fault in a circuit. There are two main types of arc faults: series arc faults and parallel arc faults. A series arc fault occurs when there is a break in a single conductor, while a parallel arc fault occurs when there is an arc between two conductors. Arc fault circuit interrupters are designed to detect both types of arc faults. Several factors can cause an arc fault circuit interrupter to trip, including loose connections, damaged wiring, and defective appliances. Loose connections can create resistance in the circuit, which can generate heat and cause an arc fault. Damaged wiring can also create an arc fault, as can defective appliances that have internal wiring problems. When an arc fault circuit interrupter trips, it is important to identify and correct the cause of the arc fault before resetting the breaker. Simply resetting the breaker without addressing the underlying problem can create a fire hazard. To troubleshoot an arc fault circuit interrupter, start by checking for loose connections and damaged wiring. Pay close attention to outlets, switches, and light fixtures, as these are common locations for arc faults to occur. You can use a non-contact voltage tester to check for voltage on the circuit before working on it. If you find any loose connections, tighten them securely. If you find any damaged wiring, replace it with new wiring of the same gauge and type. Next, check all of the appliances that are plugged into the circuit. Unplug each appliance one at a time and test the circuit after each one. If the arc fault circuit interrupter stops tripping after you unplug a particular appliance, then that appliance is likely the source of the problem. Do not use the appliance until it has been repaired or replaced. If you have checked all of the connections, wiring, and appliances and the arc fault circuit interrupter is still tripping, then the problem may be with the arc fault circuit interrupter itself. In this case, you will need to replace the arc fault circuit interrupter with a new one. When replacing an arc fault circuit interrupter, be sure to choose one that is compatible with your electrical system. Arc fault circuit interrupters are available in different amperage ratings, so you will need to choose one that is appropriate for the circuit that it will be protecting. Article 210.12 requires that arc fault circuit interrupter protection be provided for all branch circuits that supply 120 volt single phase, 15 ampere and 20 ampere outlets installed in dwelling units. This includes all areas of the home except for bathrooms, garages, and unfinished basements. However, some local jurisdictions may have adopted stricter requirements that extend arc fault circuit interrupter protection to these areas as well. When installing arc fault circuit interrupters, be sure to follow the manufacturer's instructions carefully. Arc fault circuit interrupters are more sensitive than traditional circuit breakers, so it is important to install them correctly to avoid nuisance tripping. Arc fault circuit interrupters are an important safety device that can help to prevent electrical fires. By understanding how arc fault circuit interrupters work and how to troubleshoot them, you can help to keep your home safe from electrical hazards. Here are some additional tips for troubleshooting arc fault circuit interrupters. Use a circuit analyzer to test the circuit for arc faults. A circuit analyzer is a device that can detect arc faults in a circuit, even if they are not causing the arc fault circuit interrupter to trip. This can help you to identify and correct potential problems before they cause a fire. Consider using a combination arc fault circuit interrupter. A combination arc fault circuit interrupter provides both arc fault and ground fault protection. This type of breaker can help to protect against a wider range of electrical hazards. Consult with a qualified electrician. If you are not comfortable troubleshooting arc fault circuit interrupters yourself, then consult with a qualified electrician. An electrician can help you to identify and correct any electrical problems in your home. Here are some common misconceptions about arc fault circuit interrupters. Arc fault circuit interrupters are too sensitive and trip unnecessarily. While it is true that arc fault circuit interrupters are more sensitive than traditional circuit breakers, they are designed to trip only when there is a real arc fault. Nuisance tripping can occur, but it is usually caused by a problem with the wiring or appliances in the circuit. Arc fault circuit interrupters are not necessary in older homes. While it is true that arc fault circuit interrupters are not required in older homes, they can still provide valuable protection against electrical fires. If you are concerned about electrical safety in your home, then consider installing arc fault circuit interrupters, even if they are not required. Arc fault circuit interrupters are too expensive. While arc fault circuit interrupters are more expensive than traditional circuit breakers, the cost is relatively small compared to the potential damage that can be caused by an electrical fire. In addition to the tips already mentioned, remember to inspect the wiring for any signs of physical damage, such as nicks, cuts, or abrasions. These can compromise the insulation and lead to arcing. Pay close attention to areas where wires pass through metal studs or boxes, as these are common locations for insulation damage. Check for any signs of rodent damage to the wiring. Rodents can chew on wires and create openings in the insulation, which can lead to arcing. Also, ensure that all electrical boxes are properly grounded. Grounding helps to provide a safe path for fault current to flow, which can help to prevent arc faults. Check the grounding connections in the electrical boxes to make sure they are tight and secure. Consider the age of the wiring in the home. Older wiring may have deteriorated over time, making it more susceptible to damage and arcing. If the wiring is very old, it may be necessary to replace it to ensure electrical safety. When working with electrical wiring, always turn off the power to the circuit at the main breaker panel. Use a non-contact voltage tester to verify that the power is off before touching any wires. Wear appropriate personal protective equipment such as safety glasses and rubber gloves to protect yourself from electrical shock. If you are not comfortable working with electrical wiring, then it is best to hire a qualified electrician to do the work. Article 310.15 in the NEC covers ampacity, the current carrying capacity of conductors. It outlines the requirements for selecting conductors of the correct size based on the load they will carry, the ambient temperature, and other factors. Using undersized conductors can lead to overheating and insulation breakdown, increasing the risk of arc faults. Consult NEC Table 310.15 for proper ampacity ratings. Be aware of shared neutral circuits. In a multi-wire branch circuit sharing a neutral conductor, an imbalance in the loads can cause the neutral to become overloaded. An overloaded neutral can create voltage fluctuations and increase the risk of arc faults. Ensure that the loads on shared neutral circuits are balanced to prevent overloading. Check for any signs of water damage near electrical wiring. Water can create a path for current to flow, increasing the risk of arc faults and ground faults. Repair any water leaks and dry out the affected areas before restoring power to the circuit. Consider the type of loads on the circuit. Certain types of loads, such as motors and electronic devices, can generate harmonics which can interfere with the operation of arc fault circuit interrupters and cause them to trip unnecessarily. If you are experiencing nuisance tripping on the circuit with these types of loads, you may need to install a harmonic filter to reduce the amount of harmonic distortion. Review the installation practices. Improper installation of electrical wiring can create conditions that increase the risk of arc faults. Make sure that all wiring is properly supported and secured, and that connections are made correctly. Avoid using staples or nails to secure wires, as these can damage the insulation. Use appropriate connectors and fittings for all connections. Consider the use of surge protection devices. Surge protection devices can help to protect electrical equipment from damage caused by voltage surges, which can also contribute to arc faults. Install surge protection devices at the main breaker panel and at individual outlets to provide comprehensive protection. Remember, electrical work can be dangerous. If you are not comfortable performing any of these troubleshooting steps, it is best to hire a qualified electrician to do the work. A qualified electrician has the knowledge, skills, and experience to safely diagnose and repair electrical problems. In addition to the above, consider the following points specific to arc fault circuit interrupters. Firstly, AFCIs are designed to detect very small arc faults, so even a minor wiring issue can cause them to trip. Secondly, AFCIs can be more sensitive to electrical noise than traditional circuit breakers, which can lead to nuisance tripping. Thirdly, AFCIs are required by the NEC in many areas of the home, so it is important to understand how they work and how to troubleshoot them. Finally, if you are experiencing persistent problems with an arc fault circuit interrupter, it is best to consult with a qualified electrician. Remember that these troubleshooting tips are general guidelines and may not apply to every situation. Always follow the manufacturer's instructions for the arc fault circuit interrupter and consult with a qualified electrician if you have any questions or concerns. It's also important to ensure that any electrical work performed complies with local codes and regulations. When dealing with electrical systems, safety should always be the top priority. If you are unsure about any aspect of the troubleshooting process, it is always best to seek professional assistance.